All right, guys, we're going to tackle section 2.1 or 2.2. What is it? 2.1, transforming data and density curves. So I'd probably pause the video right now and I draw these pieces out, and then we're going to add a dot plot with 6 points, 3 zeros, a 1, a 2, and a 3. So what we're going to look at is how data is affected by either adding or subtracting a number or multiplying or dividing a number. So let's look at this here. So we're going to add 5 to each of these points. So I'm going to add 5 to each of those points. I'll do it in orange. So all 3 zeros become 5. The 1 becomes a 6. The 2 becomes a 7. And the 3 becomes an 8. Okay? So if we look at it, we got to talk about socks. So if we talk about our socks, our shape doesn't change, no change. Our outliers and our center are moved by whatever we're adding or subtracting. And our spread doesn't change at all. No change. So what are we talking about here? Mean, median, those types of things like quartiles, all that stuff, there's no change. No, sorry, that's just shape. There's no change. It's still going to stay the same shape. This is what I'm talking about. Mean, median, quartile 1, quartile 3, all those pieces, they're going to move to the left. Anything that measures spread, standard deviation, range, minimum, not minimum, maximum, range, and IQR, those are going to have no change. So let's look at what happens when we multiply by 2. There's a blue one over here. So look what happens when we multiply by 2. So 0 stay here because 2 times 0 is the same. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. So let's look at what happens here according to socks again. So our shape, no change. It's going to get spread out, but there's no change to the shape. If it's symmetrical, it's going to be symmetrical. If it's skewed, it's going to stay skewed. All right, outliers. Outliers and center. They're going to change by a factor of whatever we're multiplying or dividing. Okay? So if our center was at approximately, what is that, 1.5, our center now is going to be at 3, which makes sense because we're multiplying it. So whatever we're multiplying or dividing by, our outliers and our center are going to be affected by that same way. And then if we're talking about spread, what happens to this? The spread is also affected. By the factor. Whatever that factor is. What I mean by a factor, just so you guys know, is this is the factor. I'm multiplying by 2. So the spread is going to increase by 2. The IQR is going to increase by 2. Standard deviation is going to increase by 2. Our mean is going to, not by 2, but double. Our mean is going to double. Our median is going to double. Our outliers will double. Our points will double. Everything doubles. The shape's going to stay the same. It's just going to get spread out a little bit more. Here, I'm adding a factor of 5. Everything moves a factor of 5. There's no difference in spread, so it doesn't affect that. And there's no difference in shape. So that's how we transform data. The example problem, I'm going to let you guys put your answer on Edpuzzle, and then I'll look at them and see what we can come up with, and then we'll go over it in class on Friday. So let's look at density curves. So let's just throw this one here. And just because, I'll just put a dot plot. So what we look like here is we have a bunch of dots for data. It doesn't matter what it is. It doesn't matter the number of them right now. It's just the idea of what's called a density curve. So the idea of density just means like it's all compacted into one spot or it's spread out completely. Let's just assume we're compacting all these numbers into a nice curve. So the idea is that it's called a density curve. So what we do is we take the idea of the dot plot and we create a smooth curve out of it. Okay? So that's the idea of a density curve. This is a symmetrical density curve. If I was going to draw a skewed one, let's say, looks like that, I would draw a smooth skewed one there. And then if we're looking at a skewed left, and we'll just go like this. The idea is that we draw a smooth curve here, and we've got it there. Now, a couple of features of why we draw the curve. Number one, the peak helps us find X bar and the median. Remember, so on these here, X bar and the median are usually pretty close together. This one here, the peak is going to be the median and X bar is going to be here. So we're always working with the peak on these things. We got a median here and an X bar here. Okay? So we're able to use the peaks to find the median, the mean, and those other pieces. We also use them because they have a few special properties. Number one, there's always 100% or 1.0 or 1.0 underneath the density curve, always. So this has 100% of the data, this has 100% of the data, so as everything underneath this curve is considered 100% of the data. So that means half of it is 50% over here and half of it's 50% over there when it comes to a normal one. This one's going to be a little different because it's a little skewed, so there's a less percentage of it here, but remember the total is always 100%. Okay? It's always 100%. They're always smooth. It's always above the horizontal axis, and then we kind of work with them from there. So that's the main idea behind density curves. You use the peak to find the median and X bar. There's always 100% underneath them. They're always above the horizontal axis, so this would be the x-axis if you look at it that way. And so that's basically the idea for today, guys. We'll see you soon.